Good morning, Geometry iPad Initiative students. This is Mr. Lane, again coming at you from OHS High School. This is section 9.5, the effects of changing dimensions proportionally. We're going to go a little bit different direction on this. We're going to do some exploring, try and really develop what it means to find a similarity ratio between two figures, and then find the perimeter and the area and the volume ratio. So it's going to be a little bit different direction than what the book goes, but I think it'll be the best way to go for us. So anyways, there's your objective, there's the why. Make sure you answer number 5 in your notes. Make sure you have the title in it, but I might change the title actually to perimeter, area, and volume ratios. So actually, why don't you make this your title for this section of notes. Alright, so what we're going to talk about first, we're going to talk about the sides ratio and how to find that, what it means to be the sides ratio. So it says match up any two corresponding sides and make a fraction and then reduce it. We got an example here that says find the sides ratio of the rectangles below with the dimensions doubled. So if we take this rectangle here and we double the dimensions, well, what's it mean to double something? It just means to multiply it by 2. So we're just going to multiply the 3 by 2. This will become a 6 centimeters. And then the 9 by 2 would be 18 centimeters. So to find the sides ratio, we need to match up two corresponding sides. So the 3 would match up with the 6. So all we would do is put 3 over 6 and reduce, and we have a sides ratio of 1 to 2. Okay. How we use sides ratios is if we know that the sides ratio is 1 over 2 and we know the side of the smaller one, rectangle, is 9, then we can put x for the bigger one. Then when we cross multiply, we get the larger one's length, which is the 18, which we already knew. Alright, so that's a sides ratio. Now we're going to explore the perimeter ratio. So I'm going to go back, I'm going to copy our work from the previous page. I'm going to post that on here. Boom. So now I'm going to find the perimeter of both of these. So the perimeter of this, if I add up all the sides, it would be 18 plus 6. So the perimeter would be 24 centimeters for the smaller one. Okay, the perimeter for the doubled one sorry, would be 18 plus 18, which is 36, plus 12, which would be 48. So the perimeter of the larger one would be 48 centimeters. So again, we're going to make a fraction out of this, which is 24 over 48, and we're going to reduce, so that would be 1/2. So it looks like the sides ratio and the perimeter ratio are both 1/2. How could we possibly use the perimeter ratio? Well, it'd be very easy. If I knew that the ratio was 1/2 and I knew that the smaller one's perimeter was 24, then I could slap an x for the bigger one's perimeter, and when I cross multiply, I get the bigger one's perimeter. Alright, let's move on to area ratio. So again, I'm going to copy down the new rectangle here. Erase this stuff here, we don't need it anymore. Alright, now I'm going to explore the area. So the area of the small one here would be 27 centimeters squared. And the area of the larger one here would be 18 times 6. So let's see. Which would be 108. centimeters squared. So then I'm going to make a fraction out of it just like all the other times. Okay, now I'm going to reduce this. I'm going to take a 9 out of both of these, so this would be 3, and 9 out of that would be a 12. And then this would reduce one more time. Taking a 3 out would be 1 to 4. Okay, how could we possibly use that? Well, again, if we know that the ratio was 1 to 4, and we knew the smaller one's volume was 27, I could put the x for the larger ones, and when I cross multiply, I get the larger one's area. Okay. So it all works very similarly to one another. So let's move on to volumes. Okay, so now on the volumes, it's going to work fairly similar, but I want to double all of these. So the new dimensions would be 6 for that side of the rectangular prism. Now this would be 18, and then the depth though on this one, when I double it, would be 24. So your volume ratio, is length times width times height. So on this one here, we need to multiply all three of these real quick together, which would be 3 times 9 times 12, which would give us a volume of 324. The volume of this one over here would be 6 times 18 times 24, which would be 2592. So again, we're going to make a fraction out of that, 324 over 2592. And we're going to reduce that, and that's going to be 1 over 8. Okay, so how could we use that again? Exactly the same way. 1 to 8 is a volume ratio, and we know that the smaller one's volume is 324. We stick that over x for the larger one's volume, we cross multiply, and we get the larger one's volume. Okay. Alright, so let's kind of explore a little bit on the ratios. If we're given a sides ratio, it's the same as the perimeter ratio, and then the area ratio, if we notice, if we square both of these on the perimeter ratio, we get the area ratio. Okay. For the volume ratio, notice if I cube the perimeter's ratio, I get the ratio of the volumes. So given one of these ratios, I can find any of the other ones. For instance, right here I have another set of ratios set up for us. Notice that sides and the perimeters are the same. If I square both of these, I get the area ratio. If I cube both of these, I get the volume ratio. Okay, so if I can just find the sides ratio, I can use that to set up all the rest of them. Let's do a quick example. So an example, let's say we have a, oh, by the way, let's go back for a minute. If we're talking circles, then the circumference ratio, the ratio of the circumferences would be the same as what it would be for the perimeter. So I could interchange the word perimeter with circumference right here, and it would be good for a circle then also. Alright, as an example, let's say we have a rectangle, and I know that the sides ratio is 3 to 5. Okay, Well, can I find the perimeter ratio? Well, the perimeter ratio is going to be exactly the same, so it's going to be 3 to 5. Can I find the area ratio? Yeah, if I take the sides ratio and I square it, then the area ratio is going to be 9 to 25. Okay. And let's say it was a rectangular prism, then I could find the volume ratio by coming back here and cubing both of these, which would be what, 27 to 125. Alright. Let's say we had a area of the smaller rectangle to be 100 inches squared. Well, how could I use this ratio to figure out what the larger one's area would be? Well, I could stick the 9 over 25 and the smaller one's area is 100. I can stick that over x, and now I'm ready to cross multiply to solve. Alright, so when I divide by 9, come to the handy dandy little calculator, 2500 divided by 9, boom, I get 277.8 inches squared for the area of the larger one. Alright, so anyways, this is Mr. Lane. Secret word today is going to be phone. Phone for the secret word today. Send that to me for 2 points. I'm going to go ahead and sign off from OHS High School. We'll catch you next time.